All right, so y equals 2x plus 3. And so if I plot 2 points on here, so if you let x be 0, then I get y equals 2 times 0 plus 3, which is 3. So I plot the point 0, 3. Now do as best you can with plotting those points. So there's 0, 3 right here. And then if x is, let's say, 1, I get y equals 2 times 1 plus 3, which is 5. So I'll plot the point 1, 5, which is, let's say, here. All right, and then if I draw that line, and hopefully it will go where I want it to go. All right, something like that. All right, so that's the first line. Now let's look at the other one, y equals x minus 2. Now, some of you are having, to be honest with you, some of you are having a little difficulty graphing these lines. It's like you forgot how to do this. You've been graphing lines for a long time now. So that should not have been an issue, graphing the lines. So that's why it's called pre-learning. That should not have been an issue, but it is for some of you, so it's something you got to work on. So if x is 0 over here, I get y equals 0 minus 2, which is a negative 2. So here's 0, negative 2. And then if x is, let's say, 3, I get y equals 3 minus 2, which is 1. So I'll plot the point 3, 1. Let's say that's here. All right, so I'm going to draw that line. Do the best you can with drawing that line. And I get something that looks like this. Now, I did ask you to extend those lines as much as you can because they are going to intersect. And I wanted you to tell me where they intersected. Okay, so there are the two lines. They intersect. And where do they intersect? At what point?
Negative 5, negative 7.
-5, -7. That's where they intersected? Okay, now, this says this. Which equation has a solution 5, 3? Well, all you had to do, first of all, is locate 5, 3 in the plane. Well, 5, 3 is here. And remember, a line, whenever you graph a line, you're graphing the solutions, right? So this point is on this line. So that's a solution to this line right here. And what line is that one? Y equals x minus 2. And you can check yourself because when we talked about solutions, you plug in those coordinates. The left side better equal the what? The right side. Well, x is 5, y is 3. So we're asking ourselves, is 3 equal to 5 minus 2? What's the answer? Yes. Then we look at the next one. Which equation or equations, could be both, has solution 7, 5? We'll locate 7, 5. Where's 7, 5 located? Right here. So what equation has that solution? The same one, right? Y equals x minus 2. So all these points here on that line are solutions to y equals x minus 2. Then I'm asking which equation has a solution negative 2, negative 1? Well, negative 2, negative 1 is here. That is on a line. Which one is it?
Y equals 2x plus 3.
Y equals 2x plus 3. So if you were to plug in negative 2, negative 1 into that equation, the left side better equal the right side. And you can check if this is x and this is y, which it is. You ask yourself, is negative 1 equal to 2 times negative 2 plus 3? Well, 2 times negative 2 is negative 4. And what's negative 4 plus 3? Negative 1. Then I'm asking you which equation has a solution negative 4, 3? Well, negative 4, 3 is right here. Is that a solution to any of those equations? Negative 4, 3 is right here. No. It's not a solution to any of them because it doesn't lie on any of those lines. So you can say neither or none. Then I'm asking you, which equation has the solution -5, -7? Both of them. Both of them. So if you look at these two equations separately, if you look at those two equations separately, each equation has how many solutions? An infinite number. If you look at those two equations at the same time, not separately, but at the same time, together, they have what solution in common? One solution. What is it? -5, -7. This is called solving a system of equations. So the system is going to look like this. So system of equations. Now the way it's going to look is that it's going to be a brace. It'll look like this, like a brace. And you can have your equations. Now a system of equations is where you have two or more equations and you want to find out the solution. Where do they intersect? What point do they share in common? That's what we mean by solving a system. So the way it's going to look, what we're about to do is this. You're going to be given, and we're just going to do with two equations. You'll be given two equations, y equals 2x plus 3, and then y equals x minus 2. And the directions will say this: solve this system. Well, what I mean when I say solve a system is I want to find the solution that makes both equations true at the same time. Each equation has how many solutions? An infinite number. The system, though, this system right here, this system that I just graphed, has how many solutions? One. What is it? -5, -7. That's the solution to this system. Because if you plug in -5, -7, it makes both of these true. So if you go back to this one here, 5,3. 5,3 is a solution to this one, but is a solution to the other one? No, it doesn't lie on it. How can it be a solution? It doesn't lie on this other line. This is the only line that 5,3 lies on. But -5, -7 lies on both. Okay? All right. So, let's turn the back page. So you had, on a previous worksheet, you had graphing a line where you had fractions. And as I was going around, most of you were doing fine. There were a couple of you that forgot how to do this, how to graph these lines. So when you have a fraction, we chose numbers, remember, that were divisible by that denominator. So we're going to choose numbers that are divisible by what? 3. So if I look at the first one, if x is 0, I get y equals 2/3 times 0 minus 3. So that's 0 minus 3, which is what? -3. So I'm going to plot the point 0, -3. So that's here. Oops, sorry, that's here. I'm just going to do one more point. If x is, let's say, 3, I get y equals 2/3 times 3 minus 3, sorry. The 3's divide out, so I get 2 minus 3, which is a -1. We'll plot the point 3, -1, which is here. And we'll graph that line. And do the best you can with graphing these. When you're graphing these lines, in terms of solving a system, it has to be precise. See how I have it a little off right here? So it's not, hopefully it'll still work. All right, next one, right here. If x is 0, I get y equals 2/3 times 0 plus 4. So that's 0 plus 4, which is 4. So I'll plot the point 0, 4. That's here. And if x is 3, I get y equals 2/3 times 3 plus 4, which is 2 plus 4, which is 6. So 3/6 is here. And again, I'm going to draw that line. I'm going to graph that line. And what do you notice about those two lines? Do they intersect?
No.
No, they don't intersect. All right, now let's answer some questions. Part B, list two ordered pairs that make the equation, that first equation that we did, true. Well, how many ordered pairs make that equation true? Now, when I say an ordered pair that makes the equation true, I'm also saying I want the what? The solutions, though, right? That's what it means. It means, what are the solutions? Well, they're an infinite number. I just want how many? 2. So you could have listed any ordered pair here. But choose ones that intersect where those grid lines intersect. So like right here. So that's what, -5, 1 is one of them. Another one would be, I guess here, 6, 8. Okay. All right, and then let's do ordered pairs that's on this one. And you could have chosen the ones you picked anyway. I don't know if any of you did that. You could have said, well, I'm going to choose 0, 4, and then I'm going to choose 3, 6. You could have done that too, right? I didn't tell you not to. But you could have, but pick, you could, remember, any point on that line is going to be a solution.
Mr. Go to that on part B, on number B there. Based on the way I graphed my line, I'm not sure that -5, 1 is on the line.
It probably isn't, the way because remember I told you mine was a little off? So you can always tell if it is. Just go back and substitute these. So it probably is not. Let's see, y equals 2/3 times a -5 minus 3. So that's a -10/3 minus 3. On your calculator, what's -10/3 minus 3? That's like -19/3, which is not 1, right?
6 1/3, -6 1/3.
What'd you get? -19/3. Did I draw the, is this the correct line right here? Oh, I'm sorry, I'm looking at the, shoot. This one is this one. So I plugged it back in the wrong one. I should have plugged it back into the other one. So that should have been in this one here. So y equals 2/3 times -5 plus 4. So that's -10/3 plus 4. So that's -10/3. Use your calculator if you need to, but it's really -10/3 plus 12/3, which is 2/3. So it's not quite it is 2/3, but notice my point right here. Yeah, it looks like it's over 1. So that's not correct. So I'm just going to go ahead and use the one we chose. Which one was it? 0, oops.
0, -3.
0, -3?
I didn't have.
Yeah. But I think 6, 8 works. Does 6, 8 work?
6, 8, yes.
Y equals 2/3 times 6 plus 4. So that's 4 plus 4, which is 8. Yep. All right. Okay. Now, list two ordered pairs that do not satisfy either solution, or either equation, excuse me. Yeah, there's a bunch of them, right? So -2, 5, you said? Okay, that's one of them. So, yeah, they're enough. So -2, 5. What'd be another one you could have said? 0, 0, that's right. The origin is not on either one of them. All right. So are these lines parallel, perpendicular, or neither? Parallel. They're parallel. Okay, so in terms of a system, So each line individually has how many solutions? An infinite number. Together, remember this means system right here. Together, y equals 2/3 x minus 3 and y equals 2/3 x plus 4. What is the solution? There isn't any because they don't intersect. So you're going to say no solution. Okay, you're going to say no solution. All right, now, one way to solve a system of equations is to graph. But you notice the procedure here, it's very tedious. You have to be very careful, you have to be very precise with how you graph these. If you use a very thick point, it's not going to be pretty precise. And then if you don't put the points where they need to be, if it's a little off, like mine was a little off, you may not get the exact solution. So solving a system by graphing is not the best way to solve a system. So there are two ways you're going to solve a system, though. You're going to solve a system using substitution, and you're going to solve a system using elimination. So you picked up a handout, so go ahead and take that out.